Welcome to another Days American Flyer Train video featuring American Flyer Trains by A.C. Gilbert, rebuilt and maintained to engineering practices, factory specifications, and standards, and underpinned by lessons learned from literature, personal experience, collaboration, and applied knowledge to update and advance the skill of the craft. When we last left this video series, we were about to take the dive down to do the bottom of the tender, knowing that the next step would be the reverse unit and then on to the boiler and the locomotive, knowing then we have the substructure in place to support the locomotive, and that would not be the problem if something went wrong, we hope. But if it does, we can always trace it back to here. Some of the work that's been completed was the polishing of the plug panel, the installation of the replacement knuckle coupler, because the previous knuckle coupler had fractured right at its neck or contact point right along the shaft of where it connects to the truck. So it's already been replaced. All I did was slide it in and pinch it closed, both from the side and the top. I went ahead and did a little work on straightening out the tow bar, polished it of course, but straightened out a little bit because even the rivet and the hole in the tow bar were not in alignment. So I went ahead and aligned that. I won't get to do much more work on this. There really isn't a need to until I can connect it to the locomotive and then check the relationship as I detailed in a previous video. Of course, all the axles were removed. The plastic non-contact wheels were cleaned and polished. The contact wheels were thoroughly cleaned and polished. The axles were cleaned and polished to remove the residue and the carbon burn off those. And of course, you'll notice that the spring contacts have been cleaned and polished and are ready for service. Now, in this spring contact right here is the one we had the large hole that was from the friction caused with the axle. I consulted a colleague of mine and asked him what he thought about dropping in solder into that hole as per Mr. Barker. Now, while it may work in some instances, he did not like that particular solution, or I guess I should say he didn't favor it, but favored that it be replaced with copper, which is a much better conductor than even solder for that matter. Solder's plenty hard. It should withstand this friction, but he said go ahead and use, he highly favored the use of something that's copper. So I took an old spring contact that was in my junk box that had been cannibalized from a train long ago, and I cut out a block and then cut a tab off of on one end of it. I inserted the tab into the hole and then folded it back in this direction, the same direction that I put the replacement piece, so they'd be kind of locked in. I then, of course, it was cleaned and polished. I then put a little bit of crazy glue right along the border here just to hold it in place, but I think it's going to stay anyway because of the pressure from the axle and its own pressure. But we'll see. This is kind of a proof of concept and a pilot test in production all rolled into one. We'll see how it holds up. If it doesn't hold up, well, I'll come up with another solution. I favor patching this rather than replacing it because of the work that would have to be done to drill out this rivet and replace that. So the axles and wheels are finished. And finally, I removed the springs and the slide contacts, and they have been polished, thoroughly cleaned, the spring contacts thoroughly cleaned. The shoe box, if you want to call these a shoe, then the shoe box was thoroughly cleaned on the interior to promote electrical flow. And then I made an adjustment to these, dropped them back in, but I noticed, as I mentioned in the previous video, that these shoe boxes were moving considerably, and I noticed too that they had a little bit of a different construct than previous ones. You'll recall these shoe boxes were held on with tabs. The tab was then inserted into two knobs that were on part of the truck's centered iron side frame and pushed into those tabs. These, however, the tab looked to be pushed underneath the sheet metal substructure of the truck itself. Maybe a little bit stronger construct, but nonetheless, it still rotated back and forth and rocked too much for my satisfaction. So once I got these back together, and of course thoroughly cleaned, I put a clamp on them between the centered iron side frame and the back side of the shoebox, held it in place, and then ran a small bead of JB Weld down each of the side seams. I let that dry 24 hours and then applied a little bit of coloration to it. So that should keep these shoeboxes from any type of movement, and the springs are ready to go, and so are the shoes. I've already put this on the track to make sure that there is electrical flow to the reverse unit. As a matter of fact, the reverse unit works, but it's going to get one of my thorough rebuilds. So that completes the cleaning and the rebuilding beneath the tender. So we should be able to go to the next step, which of course is the rebuild of the reverse unit. Give you a little close-up view of the work. While we're using this bottom-up logic to rebuild this tender for 336 to 484 Northern, we have an opportunity to see 2 or 3 potential or repeats of common hidden problems. So I'll go ahead and elaborate on those, because I do watch for those now that I'm very sure that they can exist. One was the lack of tension on these contact springs, and that is the contact spring was not applying maybe any tension at all downward on the axle, which is part of the pickup here from the wheel of the axle to the spring. And if it isn't applying enough tension, or downward force, there is a possibility it's just barely floating above the axle, possibly creating arcs that maybe could even either deplete the current flow, or it could maybe send the reverse unit through one of its cycles. So while I had the axles out, of course, and polishing these, right after polishing them, I start bending them a little bit and testing them, holding my finger at the contact point and bending them outward until I see that they're beyond the hole where the journal box where the axles are inserted, and therefore are applying ample pressure. Now you may say, well, that's going to create friction and drag. Well, yes, it does, but this is just necessary. Now, one of the other things I have noticed on these trains in a variety of different places is the use of grease, and I even noticed this on the Pony Express when I rebuilt that, and that, of course, is a Lionel American Flyer, and that's the use of a grease on these axles against these spring contacts. I don't favor that. I don't believe grease is intended to improve the electrical flow if it's needed at all. If you feel like it's necessary to put lubrication here, I highly recommend and endorse CRC 226. That's its purpose. It is designed to both lubricate, actually, and to clean, and to improve electrical flow or electrical contact or electrical properties. But these are providing ample, all 4 of these are providing ample pressure. Now, one way to test that pressure or lack thereof, simply to turn the piece on its back. We'll focus in a little bit and see if you press one of the wheels down, if in fact the spring contact returns it to the up position, which of course would be down if it were flipped over in an operational mode. So you can see that the spring contact is in fact returning each of these axles to the up position while it's flipped over, and therefore should be adequate downward pressure when it's on the rail head. Another possible common hidden problem, of course, I've already elaborated on, I believe in another video, was the draft between the boiler and the tender. And that is, are they in the same tubular space of air, and are they drafting properly? You remember the problem was that it is possible with this tow bar being misaligned that the locomotive could actually lift the tender up just a little bit, or put it in a configuration or a position that's not making optimal contact with the rail head. Well, I went ahead and worked on, as I mentioned, worked on this tow bar to align the ends What I have not worked on though is what does it look like exactly when it gets hooked up to the locomotive. And I'll be able to better tell when, of course, I get the locomotive finished, I have it hooked up, I'll put it on my display shells, study it very closely at eye level to make sure that there's no awkward position that this tow bar, when connected to the locomotive, puts this in an awkward position of either lifting up on the rail, above the rail head, or some other configuration. So that was another one I'll be able to check. Of course, the one is another one we're going to be able to check when we get to it is on the reverse unit. I'll explain that later. And of course, I thoroughly made sure that the slide contacts were making very strong connection with the rail head without the opportunity of pushing too far up on these contact wheels. By the way, when you reassemble these, the rule of thumb is the contact wheel goes on the same side of the truck as the slide contact. On diesels, you'll have to look at the axle a little bit harder because you're going to be looking at the chassis of the motor, and you'll want to put, again, the slide contact on the same side as a pickup wheel that does not have an insulator. You'll find on a diesel, for example, there's going to be one pickup wheel per axle that has an insulator and the other one that does not. So you'll want to put this shoe contact to make sure the axle is on the same side as a shoe contact that does not have the plastic insulator.